Stanford University.
All right, well, welcome then to CS193P Lecture 12. This lecture has a couple of parts to it. One is we're going to talk about the final project guidelines, a very important thing to know, what is required of you of the final project if you want to do well on that. And then we'll be back to normal lectures at the end, okay? I have a little bit of normal lecture. I got so much stuff to cover, I can't waste even 15 minutes of this lecture time. So we'll do that. So let's move on to the lecture part for today, our actual lecture of information. Everyone gets their notepads out for today's lecture. And today we're going to talk about persistence. Okay, so what does that word mean, persistence? Persistence means it stays around when your app quits. Now you already know of one thing of persistence, which is NS user defaults. Very, very simple kind of persistence thing. Lets you make a persistent property list, basically. But it's limited because it's got to be small things. It's really user preferences. So today we're going to talk about what if you want to persist big things, okay, important, the user's data, you know, some image that they take with the camera or something that you then modify or whatever, you know, something that's big, or some document that they create, okay? We're going to talk about how we make that stuff persist. Now, the first step, the first kind of simple way to make things persist is a little bit of a step up from NS user defaults with property lists, okay? So I told you that property lists were just a concept that we define the name of, right? It's any combination of NS array, NS dictionary, NS string, NS data, NS date, and NS number. So any graph, any combination of that. And I told you there was API that you could use to store that. And of course, NS user defaults has some API to do that, like set object for key. And there's also methods in NS data and NS array and NS dictionary. Most importantly, write to URL, atomically, okay? So all this does is you send it to an array and it writes it out to a URL that you specify in your file system. We're going to talk about the file system in a moment here. And atomically just means that if that file already exists, it moves that file aside, writes out the new one, closes the new one, and then, or actually probably writes it to a new file with a temporary name, closes it. Once it's there, then it moves the other one out of the way, kind of atomically. You know, you can't get in a situation where it's half written, right? That's all atomically means. But so write to URL, and then to get it back, you can do init with contents of URL, or there's also data with contents of URL, or I think there's probably array and dictionary with contents of URL, and it'll just read it back. So these reading and writing to URLs of property list, even though you send them to an NS array or to an NS dictionary, to an NS data, and you would obviously want to ask the same kind of object to read it back, inside it could have all the property list things, right? So when you say to NS array, write this property to an NS array, which is a property list, as long as nothing inside it is not a property list. When you say write to URL, anything, any property list thing can be in that array and it'll work. Okay? Make sense? So that's a simple way to store some more data. Now, you might ask, why would I ever do this versus NS user defaults? Well, again, it's a size thing. You're not going to put something that's, you know, 100K into NS user defaults. The NS user defaults is for small things. That's why it's called NS user defaults, okay? It's for settings and things like that. So this would be if you wanted to have your document format be a property list, and you're going to write these documents out, okay? So this is one way. Now, there's a class called NS property list serialization, and what it does is it takes a property list and turns it into an NS data, and vice versa. Okay, so it basically takes property list and turns into a bag of bits that you could then write out to disk, or maybe store over the network, okay, or read over the network as a bag of bits, and then NS property list serialization can turn it back into a property list, okay? So that's another way. Go through an NS data and then you use NS data's API. So property list, that's one way to do persistence. Not super common to do it this way, but I figured it's important to know that it's there, all right? All right, so I just want to throw property lists up front because you're already familiar with the concept. So the other ways we're going to talk about storing things are archiving objects, which is putting arbitrary graphs of objects into storage, not just property lists, but arbitrary graphs. Storing things in the file system. Okay, what does it mean to store things in a file system on the iOS? You probably can imagine that on your Mac, what it means. You see the file system all the time in the Finder, but there's no Finder in iOS, so what does it mean when we say store things in a file system? Then we're going to talk about SQLite. Okay, SQL is a database programming language, basically. How many people in here know what SQL is? Okay, everybody pretty much. Okay, that's good. Now, I'm not going to expect you to write any SQL in this class, not to worry. Luckily, we have an object-oriented database on top of SQL, so we'll be doing all object-oriented programming. But I'm going to show you the SQL API as well. It's a C-based API, very simple. And then the big one for persistence is core data. That's this object-oriented database mechanism on top of SQL. And we're going to talk about that all next week. So I'm not going to talk about that today. We'll talk about all next week. That's what all next week's about. We're going to talk about how to integrate these objects in your object-oriented database with table views. And we'll cover core data in pretty good depth. And even then, even taking a full week, we're still only get to the basics of it because it's a pretty rich API. Okay, so let's talk about archiving objects. I'm going to go through this one pretty briefly because you're never going to do archiving objects in this class. Okay, this one is one when I talk to students about it and I show it to them, they want to latch onto it and like, whoa, that's great, that's excellent, because I have this data structure of objects that I've written, and they're not all property list objects, and I want to make them persist. Okay, but there's a lot of pitfalls with doing archiving in terms of the object graphs. Archiving is awesome in that it deals with things like loops in the graph. Like imagine UI view hierarchy. There's loops there because, or there's back pointers anyway, right? Because you got your subviews, and then subviews have a pointer to their superviews. So archiving deals with that. It figures out, oh, this pointer, you know, is pointing to this actual object, pointing to each other, and when it unarchives them, it reestablishes that pointer. So it's really cool in that way, but it's also something that you really need to think about architecting your object graph to make sense. And the best example I can think about for that is the view hierarchies you build in Xcode, right? When you drag things out into your scenes in Xcode, what's happening there is you're actually dragging those things out. It's actually instantiating UI views, instantiating UI view controllers, all generic ones. That's why we have to go into the inspector and change their class there. And so in the storyboard, they're all generic, and then when they get created on the other side, they'll have your specific subclass. But you're actually creating them, and then when the autosave happens, or when your document is saved, your storyboard, it's sending messages to all those objects saying, archive yourself out to disk. Okay, and it does that in an XML format, which some of you have seen. Sometimes you didn't want to see it, but you saw it. Okay, that's when your storyboard all of a sudden looks like text, right? That's the XML version of it. And you know, someday go take a look at that. You can go to the version view of the in Xcode, and if you go to the version view of a storyboard, you'll see it as text, and you can kind of look through, and you'll see that it's basically describing all the objects, and the objects are the way that happens is the objects describe themselves. But it's a graph of complicated objects, the UI view. UI views inside UI views and all frames and bounds and all those things, way more than just property lists here, okay? We're talking about a complicated mechanism. And the way that this works is all the objects in the graph have to implement the NS coding protocol. And this protocol has two important methods in it. One of them is encode with coder. That's how you put yourself into an archive. And then init with coder. That's how you come out of an archive. Now this is why view controllers and views that come out of a storyboard do not call their designated initializer, because they're using this initializer instead. Okay, the archiving system is alloc init with coder on them. Alloc init with coder on every single object that comes out of there. Alloc init with coder. And they've written themselves out with their encode with coder, so they know how to init themselves with coder. Okay, does that make sense? You see why now you don't get init with frame called on these UI views? Instead, the frame is encoded with encode with coder, and when it gets init with coder, the frame's in there somewhere. Okay, so what do these methods look like? Yeah, and like I said, it's extremely unlikely you'll use this in your course. You definitely won't use it in the homework assignments, almost certainly not in your final projects either. But here's what encode with coder and init with coder might look like. So let's say this looks like it might be something, maybe a graph view or calculator graph view or something. And so encode with coder, the first thing it does is call supers encode with coder so that your superclass gets encoded. And then it just encodes all the properties of this object necessary to reconstitute it, right? And there's a lot of methods in NS Coder, in the class NS Coder, like encode a float, even encode these C structs like CG point and CG rect, and you can encode generic objects. And when you encode a generic object, this is where it figures out the back pointers. So if you encode this NS array of subviews, those subviews will have pointers back to the superview, and it'll do the right thing when both sides of that get encoded. Yeah.
Can you give an example of what a coder is?
What an NS coder is? It's just an object that you don't know how it works or what it does. It does all the work. That just provides this API of things like encode a float, encode a CG point. It just provides that API to you, and you call it. And it's just accumulating the stuff that you're saying. You don't know how it's doing it or what's going on behind the scenes. You're just given this object, NS coder, and you can just send these messages, encode messages to it. That's all you know, okay? And so then, when it's time, so that stores it, we're going to see in the API here, that you archive stuff usually out to an NS data, right? So you've got an NS data where this coder has written all this stuff for you. And then when it's time to load it, you get an NS data, and it goes, and you call the archiving stuff, and it starts doing init with coder on everything. So you have to make sure your init with coders match your encode with coders. But it doesn't have to be in the same order, because you'll notice that when I say coder encode float at the top, I say encode float for key. So it's named, right? The properties are all named. They don't have to be in a certain order, and then in the backwards order, for example, coming out the other side, you just get them by name. All right? And notice again, init with coder, I got to call super init with coder. So when you're encoding, no designated initializers are involved, only init with coder. That's the only init that's going on. Okay? So again, you don't have to know any of this because you're not going to do any of this. I just want you to know it exists, that there is this way to do it. Usually if you're going to have a sophisticated object graph that you're going to store it in core data, okay, using this SQL-based core data, because it's just 10,000 times more efficient than loading an entire graph out and all back in. Question?
Does the init with coder call awake from nib?
So the question is, does init with coder call awake from nib? And the answer is no. The storyboard loading stuff calls awake from nib. But that's a really good question. The storyboard stuff uses init with coder to get everything built up, but it calls init awake with nib then on all the objects that are in there. But that's a great question. All right, so how do you get this to happen? You have these two important classes, NS-keyed archiver and NS-keyed unarchiver, and they have these class methods like archive data with root object. You pass a root object, so for example, in a storyboard, a root object could be the top level view controller, okay? And that's got to be NS coder compliant. It has to implement that protocol. And you just say, get me an archived NS data that archives this object and all the rest of the objects in the graph. And you can see how this is just going to send encode to all of them. Encode with coder, encode with coder. It creates the NS coder object that goes and does this. So all you have to do is make sure all the objects in there implement the NS coder protocol, okay? And then unarchiver is the opposite. You give it an NS data that archive stuff was put into, and you say, give me the root level object that was encoded here. And it's going to do init with coder on all those things and go down the tree, okay? So what do you think this code does right here? So if I have an object and I say keyed archiver, archive data with root object, and I get an NS data with that object, and then I just say ID NS coder dupe equals NS keyed archiver unarchived object with data. That would actually be NS keyed unarchiver. That copies that object, okay? Because I encoded it out to an NS data, then I loaded it back in. I got a copy. Now, you want to be careful with this because, and this is a deep copy, right? It's not just copying the top level, it copies all the way down. But you have to be careful. You know, if you encode a view, does its super view get archived and unarchived? And the answer is not unless it's down in the hierarchy, right? If it's at the top, it doesn't. But if it's down inside, it does. So you have to be a little careful when you're doing that. But anyway, so that's just, I only bring this example up to kind of make sure you're understanding what the archiver is doing. It's just basically putting all the objects into an NS data, and then you can pull them all back out. Okay? Okay, let's talk about the file system. iOS fundamentally underneath is Unix. Okay, it's a BSD Unix variant called Mach, and so you got a Unix file system under there. And in fact, you are able to see the Unix file system there from root all the way down. But of course, there's file system protections as well, so you can't see everything, and you certainly can't write everywhere. Okay, that's very important. In fact, you can only write inside what's called your sandbox. Okay, and why are you restricted to writing only in your sandbox? For obvious reasons, for security. You don't want anyone damaging your application by writing in your space that you can write in, and you don't want to be able to damage someone else's application. You also want privacy. Okay, you want whatever data your app is collecting. You don't want other apps to be able to look in there and start to see it. And also, a really important one is cleanup. When someone deletes your app from their device, they want all its data to be gone too. Okay, and so by writing in the sandbox, all of your application stuff, whether it's stuff that the user has created with your application or the application itself, is all in the sandbox. So if it got removed, it all get removed. Now, iCloud changes that a little bit, because if those documents are stored in your sandbox, and also if they're stored in your sandbox, but then the user has iCloud turned on, then they're actually stored in the cloud. So deleting the application is not necessarily going to delete the documents. Right? They might be stored in the cloud. And we'll be talking about iCloud a little later in the quarter as well. So what's in the sandbox? Well, one thing is your application bundle directory. And the application is not one single big binary. It's actually a directory. And inside the directory is the executable, the binary, and your storyboards, any JPEGs that you've dragged in, all that stuff is all in there. Okay? So that's your application bundle. That directory inside your sandbox is not writable. You cannot write into that directory. Okay, some people get a little flummoxed by that, but you cannot. Okay, that is basically a read-only copy of the application you built in Xcode. And we'll talk about what if I want to write in there. We'll talk about it in a second. A very important directory in your sandbox is the documents directory. That's where you store what the user perceives as their documents. Okay, things that they create, whatever. That stores in the documents directory. There's also a caches directory. This is stuff that you might write out that the user didn't perceive as a document and that is ephemeral. If it went away, it wouldn't affect the user. They wouldn't have lost any data in their mind. So when you do your file system cache in assignment 5, you're going to want to write to the caches directory. Okay? Because all you're doing is caching those Flickr photos. If that directory went away, you can still get those Flickr photos again. Right? Request them from Flickr again. So it's just a cache. And there's other directories in there. The key thing you want to search for in the documentation is NS search path directory. Okay? Write that down. Remember this slide. That's where you're going to find the different kinds of directories that are in your sandbox. So how do we get those directories? How do we get a URL of those directories? So we'll talk about that. Let me also briefly talk about this thing of what if I want to write to my application directory? And the answer is you can't. And what you do is you've got to copy stuff out of your application bundle and into somewhere else in your sandbox that is writable, and then write to it there. Okay? Simple solution. That's the only way to do it. So if you ship your app with a database, preloaded with some database, and you want to write to that database, you've got to copy it out, either into the documents directory or maybe a caches directory or somewhere else. And then you can write to it. All right, so how do you get the paths to these directories? So this is kind of an old slide here. If you search for NS search path directory, you'll see the newer API. I think there's an API in NSURL, for example, for getting a list of URLs. But the bottom line is that it's the same mechanism, which is that you pass the kind of directory you want, like documents directory or caches directory. You see the things at the very bottom of this slide. You pass that as the first argument to this case. We're using the C function, but there are methods also. You pass that, and then you pass this domain mask, which on iOS we're always using user domain mask. This API is the same as it is like on the Mac, and so it's got a lot more flexibility in the Mac, but we don't need that much flexibility in iOS. And then expand tilde, that's for the home directory tilde thing. We'll always say yes on that. But notice that this function and also the methods like in NSURL, it returns an array of paths. So I'm asking for the cache directory, and I'm getting an array of URLs or an array of in this case, file path strings. Why am I getting an array? Well, the answer is, if I was on a Mac, I might be getting, like if I was asking for the library directory, I might be getting twiddle/library, and then I'm also getting like my machines/library, and then maybe I'm getting /network/library, or I'm getting multiple paths where library stuff is stored. But in iOS, there's almost always only one path, and we're usually using last object, the NSArray method last object, to just grab that last one and use it. Okay, and that's what you'll be doing for your homework assignment when you're getting your caches directory. And in assignment 6, you'll probably be putting stuff in the documents directory, and you're just going to use last object. And like I say, I'll try and update this slide before I post it. The NSURL, I think, has a class method called search path URLs for directories in domain or something like that, that'll give you an NSArray of NSURLs. Because really, it used to be in iOS that you specified paths in the file system using strings, file path strings, but now we're going towards NSURLs. Okay, we use NSURLs to specify HTTP : blah, 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 but also we use them to do file : blah, 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 to have a file URL. Okay, now, NS File Manager, very important class. This is the thing you're going to have to look in the documentation and figure out how to use for yourself. It provides utility operations for operating in the file system. This is not a class for writing and reading files themselves. Okay, the data inside files is usually written using the mechanisms on previous slides, like the property list thing or something like that. Or you're writing it through core data, where it's kind of automatically being written for you. This is more like in your homework, for example, you're going to get this image data from Flickr, and you're going to want to write it into the file system because you're supposed to cache it. Well, you're going to use NSData's write to URL to put the thing in the file system. So NS File Manager, though, you're going to need that to find out how big the files are, remove files that are old, that need to be thrown out of the cache, to find out what files are in the cache, like when your application starts up. You see, you're going to need a utility operation to see what's going on in the file system. That's what NS File Manager is for. It's thread safe as long as you don't use an instance of it in 2 different threads, but you can create a new instance in every thread if you want, and they can all be happily banging away on the file system. They'll be thread safe. There's a shared one, NS File Manager, default file manager that you can use, but again, don't usually use that one. We only want to use in the main thread because we don't want some other thread to be using it at the same time. Or you can just alloc init, NS File Manager alloc init, and then off you go. Do whatever you want in whatever thread you're in. That's what we usually do. And you can see some of the examples here. You can create directories. You can see if files are readable. You can get the contents of directories, all kinds of fun stuff. And I'll leave it to you to go figure all that out. Okay? NSString also has some file system stuff, especially manipulating paths. So you have NSURL to specify a URL, but sometimes you build up that URL with a string. And the string methods like a string by appending path component will create, add subcomponents to a path and put the proper slash or backslash or whatever is required in between. You can also take the contents of a string and write it to a file, just like you can do with an NSData. Using write to file. But when you write a string to a file, you have to specify what encoding it has. So like it's ASCII or ISO Latin 1, or what is this encoding, Unicode, some Unicode encoding. And you can also get the string back out of a file. So you can actually write and read files with strings too. All right, so the last thing today is SQL, SQLite. So SQLite is SQL in a single file, okay, stored in a single file. It's fast, it uses very little memory. It's very good using memory mapped files to not use a lot of memory. And it's very reliable, transaction-based, true SQL. It's open source, but it comes bundled in iOS, so you can use this API in iOS. I don't expect any of you to use SQL in your final projects, but if for some reason you're like a SQL expert and you know how to use it, it's okay if you use it, if you want to use it. It's not really good for everything. Like I wouldn't put big video in there and things like that. I would store those directly in the file system as files that I manage. Even big sounds or images I probably would not use SQL for. But anything else, this is a reasonable sized chunked thing, I think SQL can be quite good for. And this is not a server-based SQL, okay? It's file-based. So it does do concurrency. So if you had 2 threads in your app, both writing to a SQL database, that would work, okay, because it does concurrency, but it's not great at concurrency, so you wouldn't want 100 threads all banging on it because, it's doing very simple kind of thread lockout and concurrency. And you can understand why that is. On a phone, you don't need that much concurrency, right? You pretty much users running one thing at a time, or at least paying their attention to one thing at a time. This is what the API looks like. You open a file. Notice it's a const char star. This is a C API, not an object-oriented API. So you open the SQL file that you're looking at. You get back a database pointer, a SQL database pointer, and then you just execute SQL statements, right? You pass the database, the SQL statement you want. A lot of SQL statements will have callbacks where they're giving you the data that you're requesting in a table, and you can get error back as well. The callback has this form, my callback, a void star, which is that same context you pass in the previous one, and then how many values you got and what the columns were, and then you close it. So it's a pretty simple API. You do all the programming here with the third line in yellow, which is that const char star SQL. Okay, that's where you're executing SQL statements. That's where the programming is happening using SQL, not using C or Objective-C or anything like that. So again, we're not going to do this because next week we're going to learn about core data. What core data is a fully object-oriented API that underneath the covers is going to be writing SQL statements for you. It's going to be figuring out what's the right SQL statement to do this query or to store this document or whatever. So that's going to be all handled for us. All right. And tomorrow's section, Time Profiler, should be an interesting one if you want to figure out how to find out where everything's going time-wise in my app so that you can spend your time optimizing the things that really matter. Then the Time Profiler is a good thing to know. All right, any last questions? Okay, great. Core data next week, Time Profiler tomorrow. Thank you. I'll be here only briefly. I have a thing to do with the D-School, so I'll be here just for a moment.
For more, please visit us at stanford.edu.